traversing a graph means running your pencil along the edges. Sometimes you can do it without lifting your pencil off the page. Sometimes you can't. And that's an example. Is that traversable or not? Is that traversable?
Yeah.
And if not, why not? How do you know instantly whether it's traversable or not without trying? Look, what I mean by traversable is, can I do something without lifting my pencil off the graph? Can I go around here?
No.
No. Well, I didn't then, did I? And I probably can't. And why not? What's the rule, remember?
More than two odd numbers mean.
Yep, there's a 3, there's a 3, there's a 3. That's enough to say that it's not traversable, isn't it? No more than 2 odds. Look, anyway, this lesson, this exercise, uses this illustration to talk about the different kinds of ways of traversing a graph. Now, I find a little problem with that because you can't actually traverse this graph, but you can part traverse it, you can do some things with it. And there are 5 things that you've got to learn and distinguish, or your notes have got to help you distinguish when you come to do a test. There is something called a walk, a trail, a path, a circuit, and a cycle. Those are the 5 components that we need to identify and know how to use. Now, they're ordinary words. You know what walking is generally just going for a stroll somewhere. The trail is probably a marked out walk. I find them a bit sort of artificial, these distinctions, but they've got to find some words for the different things you can do. So let's have a look at them. You don't need that diagram particularly, but it's the same diagram every time. Now, here's the definition of a walk. It is just any traverse which starts at one vertex and finishes at another. And the reason we use these, by the way, is we're going to use them in exercises F, G, and H. So starting at one vertex and finishing at another. So the only restriction on something called a walk is that as long as you don't finish where you start. So you start wherever you want to start. Now, that is a walk, but that is a walk as well.
What about A to C? Is that a walk?
A, B, C, yeah.
No, A to C.
Yeah, that's a walk as well. They're all walks. And that's a walk as well. That's a walk as well, starting at E. As long as you don't finish up at E again, that is a walk. So just remember the vertex definition, walk definition. We're going to use the word walk in terms of networks. You're going to get questions that says, is this a walk or is it a trail? In the exams, yes. I don't teach you I don't mention anything that's not going to be in the exam. So that's the first one. All right with the walk? No, you don't have to write them down. They're in the textbook. But does it make sense, what I've just said? A trail, the second one on the list, it's a walk, but it's got no repeated edges. Now, that implies to me that this one, if I'd gone, I better start again on that one. This is a walk. That's a walk, because I started at one vertex and finished another. It doesn't say I can't go over the line again. There's no restrictions on a walk. You can go backwards and forwards as many times as you like. As long as, yeah, it just depends on where you finish. Whereas a trail, it's a walk, but it's got no repeated edges, so I can't do that. I can only do that. I can't repeat the edges. Now, what I've done on the slide is I've put the definition on the side, which is out of the textbook. But this is not in the textbook because it's in the textbook, but you have to keep looking back. Whereas here, I put it all on. So it's a walk, which is one of them, in case you've forgotten what a walk is. No repeated edges. So a trail, the difference in a walk and a trail, same thing, except that trail's got no repeated edges. You can't do that. Okay, now here's a path. So what's a path? So here's another restriction on walks. This is a restricted walk again, no repeated edges and no repeated vertices. So I can't do that because I've gone back to C. No repeated edges or vertices. That wouldn't be a path. Whereas going back to the original walk, and the fourth one, or was it the fifth one? Circuits is a trail that starts and ends at the same vertex. Now, if you remember, a trail's got no repeated edges, so a circuit ends at the same vertex. So there's 3 definitions here. You know what is a trail. So from, I didn't write down what a trail was. Yeah, a trail is no repeated edges, yeah. So as long as I finish up where I start, that is a circuit. But this is not a circuit. Why not? Because I've got repeated an edge, yeah. And the last one, a cycle. So it's a trail that starts and ends at the same vertex. As long as you finish up where you start, walk with no repeated edges. So that is not one. That is not one. That is a perfectly good circuit. Shh. And cycle finally. Path that starts and ends at the same vertex. So you've got to finish up where you start. No repeated edges and no repeated vertices. So there is a cycle. No repeated edges. Okay. I'll put the definition of a path in case you've forgotten. No repeated edges, no repeated vertices. So they're basically getting more and more restrictive. 6E, you can identify and distinguish different ways of traversing a path. Now look, they use these words in the technology. This has not just been made up to keep you alive or anything. They do use them, these terms, in networks, which social networks, sewerage networks, the poo pipes, or they are the same thing. Telephone networks, come on, radio networks, aeroplane route networks, bus networks, tram networks, train networks, water networks, even a river system is a network.